Hey guys, welcome back. So it's been a while since I've done any kind of update on the big monster truck here, but I'm at a point now where I want to reposition the rear axle so that my new double cardan drive shaft pinion angle is correct in the rear. So this truck had a standard front and rear universal joint, but it made the driveline angle too extreme. And what happens when you have a driveline angle is too extreme, you get a heavy vibration, either acceleration or deceleration, as well as you can damage the axle pretty easily. It's what makes it real common to see big lifted trucks that throw drive shafts out of it. So I went with a double cardan U-joint up on the transfer case, and then I still have the standard U-joint down at the back, but this allows me to have a more extreme drive shaft angle that'll better control the drive shaft, and I don't have to worry about any kind of crazy vibrations. But the thing I need to change is, with standard U-joints, you want equal but opposite angles, meaning that the pinion angle coming out as well as the transmission angle coming out when the drive shaft goes down, those angles are the same but opposite. And what that does is it cancels each other out so that you don't have any kind of vibration. Double cardan U-joint, both universal joints are at that joint, and that's where all the angle is taking up. So what you need to do is, from the pinion angle, you need to now point that so it's in almost a straight line with the drive shaft itself. With a leaf spring suspension, you want no more than about 2 degrees down, and that's to take up for when you accelerate the spring wrapping, so that pinion angle is going to rise a little bit so you don't get a vibration that way. Fortunately, this thing is on a pretty big spring lift. It has blocks on it. It has a pinion adjustment wedge already. But the amount that I need to point this thing up, it just makes more sense for me to cut the perches off of the rear axle than to try to make or add any more pinion shims. You don't want to add a lot of pinion shim. It can become dangerous. They could slip out, and then you have all kinds of other scary issues. So what I'm going to do is I'm going to cut the perches off the rear axle. We'll clean it all up and weld them back on at the correct angle. So before I do that, I just want to show you guys real quick how I'm determining the angle on the drive shaft. This is what I'm talking about. So the pinion angle here needs to be just about in line with the drive shaft. And there's my double cardan U-joint right there. And that is what's taking up all the angle that I need to bring this drive shaft down. So I've got an angle indicator here. It's showing me about 13 degrees. And then here, this one's a little off right now because I don't have anything supporting the axle. But when I go and cut these perches off and put my blocks back, I'm going to loosely tighten everything up. And then I will come back over here and I will adjust this angle. So it's probably around 12.5, 12.8. Which is very close to this. Like I said, I want about a degree down on the pinion so that when I'm accelerating, this pinion is going to rise a little bit, and that'll give me a 0 degree angle at this universal. That should make it so I don't have any kind of vibration both accelerating and decelerating, because when I decelerate, this pinion is going to want to go down, right? And if I'm already at 1 degree, I don't want it to go down too extreme, which can bind this universal. Alright, so back onto the truck here. See, we've got a pretty substantial weld here. I think the best way I'm going to go about doing this is I'm going to take the plasma cutter and I'm just going to try to cut through this weld to save the bracket as best I can and not cut into the axle tube. I don't want to weaken that thing up at all. I got to do it on both sides of that bracket as well as both sides of the axle. So I'm going to fire up the old plasma cutter, try to cut this thing off. Okay guys, so part of the saga going on here is wiring. I've got four-wheel drive modules here, all the wiring. This is basically the dash harness. And you can see the throttle pedal. Got some other part of the harness here. What I'm trying to do is eliminate anything I don't need for this swap. But just to make sure, I'm trying to label all the wires before I remove them, so I know what they're for, and if I have any issues later, it's still there. There are a lot of things I will need, which is under here, like the brake pedal switch. This is all the ignition wires that I could still wire into the older column. Obviously, I have all the relays and fuses here from the 7.3 fuse box, which I'm going to try to use, even though I know a lot of it's not going to be used. But either way, I'm labeling all the wires as I remove them. But yeah, this is a huge, huge undertaking. There's the ALDL connector for diagnostics. I've got the whole engine harness here, and this is some of the harnessing that I pulled out so far. This here is the ABS, not the ABS, this is the airbag module wiring. Obviously this is the climate control and all the wiring there. I'm not going to need that, but I've got wiring diagrams out. I've got a label maker trying to make labels. I've got two monitors going with wiring schematics. I mean, my own little sheets here, so I know which wires are which and what they're doing as I'm going through this. But yeah, I just wanted to show you guys, you know, exactly what's involved to do something like this. Now, obviously, I could find just a few power wires I need to run the engine, but you know, a lot of the stuff for the PCM runs through this harness too. Like I said, the brake switch, the pedal here, the accelerator pedal. You know, there's the inertia switch here. Where's it here? The inertia switch here to run the fuel pump, fuel gauge. I mean, it's all over the place. So I just wanted to touch base with you guys, let you know what I have going on here. Alright guys, back on the truck here. There are a few updates that I wanted to show you guys, so you see where I'm at. I think the last thing I filmed was cutting off the spring perches on the rear axle so I can get the rear axle positioned correctly for the double cardan drive shaft upgrade I did to this thing. I'll show you guys how that went. I did end up sending the drive shaft out to get balanced, and now that I have that back, it's installed. I also went ahead and I made the bracketry to mount the speed sensor relocation. I don't know if I mentioned it, but I got a kit that is intended for a Bronco, which uses a different size transfer case, so I had to make this one fit the transfer case that was on the Powerstroke. I forget, this is a 4R100 transmission, if I'm remembering correctly. So it has a different transfer case than what you would see in a standard overdrive transmission from like a Bronco. So I had to get creative in making that work. But now that that's there, I also bought from Dakota Digital the speed calibration module, for lack of better terms. The other thing is, since this engine and drivetrain came out of a Powerstroke and a Super Duty, the speed sensor being in the rear axle sends the signal to the ABS module, and then from the ABS module sends it to the ECU, the cluster, the four-wheel drive module, basically all over the truck. I needed that module to set the pulse per mile so the computer was reading correctly. This truck does have a mechanical speedometer. We kept the factory dash that's in here, but I do have an electronic speed driver, so basically an electric motor that drives a cable that'll at least make the speedometer work, so that's a pretty trick. But since I didn't have an ABS module here, the Dakota digital box was able to buffer and calibrate that signal from my now relocated speed sensor, so that the transmission computer and the engine computer can see road speed and change the shifts accordingly, so everything is working. Without it, I was getting the overdrive light was flashing and it was throwing me a code for speed sensor. I've only driven this thing very slowly down the road because I still need to do a full nut and bolt check on this thing, as well as make sure the fluids are topped off right. I basically want to get this thing pretty well buttoned up before I go do any kind of real driving on it. So let me show you guys underneath the truck what I've got done so far, and we'll take it from there. Okay guys, so as you can see here, I've got my spring perches welded back on. I eliminated the wedges that were here. Like I said, as you saw, I cut the perches off and I positioned the axle so that I had basically no more than 1 degree of angle between the pinion and the drive shaft. That is because all my angle compensation is coming from the double cardon U-joint up there at the transfer case. So after I got that angle set, I re-welded the perches back on. I have my spacer blocks back with the bump stops there, not that they'll ever hit up there, but that stuff is all back into place. Both sides, a nice heavy duty weld, and then I kind of hit it quick with some paint. Not that it really matters underneath this thing, but just enough to protect the weld there. So now looking from the other side, I look at it at a side angle. I know it's really hard to tell on camera, but this thing is basically in a straight line. The only difference there is about 1 degree of down tilt on the pinion, and the reason for that is no matter what, on a leaf spring car, that pinion is going to go up when you're accelerating. So you want that drive line angle to be as close to neutral as possible under load. That way the universal joint will last nice and long and you won't get any binding or any issues with that. You can see it's balanced, so I have a nice balanced drive shaft. And then if we come up towards the top here, you could see where I got creative with the now relocated speed sensor. So any of you Ford guys out there know that a lot of the late model stuff, the speed sensor is located in the rear axle. There's a reluctor ring that's mounted to the ring gear. Obviously I don't have that because I use the gear, well, the rear axle that was in this HighBoy. And then since this kit I bought was for a Bronco, the output shaft section here on a Bronco is much shorter. There's a sort of a flange where you can bolt, they have just the bracket with a real short sleeve to it. I couldn't do that. Luckily though, these 2 bolts here were in the right realm. I did have to remake this bracket here. I basically copied their design. All I did was relocate the hole where the sensor is so that it was within the arc of the, what do I call this? The tone ring. So this is just a piece of aluminum that has magnets on the back side for the sensor to pick up. So once I had that where I needed it, everything lines up. I still have a little bit of adjustability. I have to put the retaining screw in yet and tighten this down once I know everything is working properly. But that was it. I basically took a piece of metric threaded rod, tightened the nuts down here so I know that the case is nice and tight, put the bracket on, my spacer, and then a retaining nut here to hold the plate. So that's basically what I needed to do to take care of, at least mechanically, the speed sensor. But like I said, this speed sensor went through the ABS module. So the way I got around that was this signal here goes up to the Dakota digital box where the signal is converted and then output into the ECU and everywhere else so that I can read road speed to the axle after the transfer case. And the benefit for this is, now no matter if this transmission is in low, four-wheel drive, whatever position it's in, I'm getting actual road speed. So the alternative is on the R1, what is it, the 4R100, there are two speed sensors in that transmission. There's an input speed sensor and then an output speed sensor, and the computer uses it to determine, you know, transmission slippage and torque converter lockup and stuff like that. I spoke to Dakota Digital and they said I could use that output speed sensor, but like I said, if I did do that and this transfer case was in low, I would not be reading actual road speed. For some of you, it might not matter. You know, if you don't care what your speedometer is doing there, but you know, if there is a way to do it, I like to do it the right way. So that's why I went with the relocation kit and used the factory sensor and then calibrated it so that the ECU can read it properly. So let me take you guys up into the cab. I'll show you some of my wiring mess. I say wiring mess because I took a lot of time trying to clean up the modern harness, so the 2002 Super Duty harness, and remove everything I did not need for this application. ABS, body control stuff, you know, power windows, the trip computer that's overhead, stuff like that. So that harness was relatively tidy. I did end up removing the factory fuse box from the HighBoy. Now the reason I did that is this used the old tube fuses, so those glass bus fuses, and you know, they could be problematic as well. But you know, since the truck itself only had you know, not even a handful of circuits, you know, headlights, tail lights, ignition, I mean, it is basically nothing. The blower motor, I just integrated it into the circuits from the 2002 fuse panel, and that way that fuse coordinates to the system it is protecting on the truck, so that anytime you need to diagnose anything down the road, if a fuse blows or something's not working, you need to check a fuse, you can go to the appropriate fuse. Downside, that fuse box has a lot of circuits that aren't used at all anymore, but it had all the relay controls in it and all the other wires are color coordinated, so I can go onto a 2002 Super Duty wiring diagram if I have any issues with the transmission or the engine computer or the engine itself, and be able to diagnose what might be going wrong. So with that said, let me take you up to the top of the truck and I'll show you guys what's going on. Today what I'm going to work on is I'm going to install the Dakota Digital speedometer driver so that I can have a speedometer on the dash. So my dashboard should be completely functional, which wasn't even completely functional with the old big block that was in here. So that should be pretty cool to see. It's a pretty trick device. I can use Bluetooth from my phone to calibrate it as we're driving. I don't need to try to push buttons in it. It's also completely sealed so that you can mount it basically anywhere. They do recommend not mounting it underneath the vehicle for road debris reasons, but it can be mounted underneath the you know, the engine, in the engine compartment, and then you run the cable, whatever electronic wiring you need, where it needs to go. I'm going to try to put this behind the dash just to keep everything a little more tidy. I have all my power grounds and my speed signal already in that location, and the cluster's there as well, so I can make my quick connection into the cluster with that, and I should have a functional speed sensor. Let me get this speed sensor set up and get into calibrating the speedometer. Alright guys, so as you can see, I've got most of this dash back together. I don't know if you can see, but I am waiting for the volt gauge to come in. I found a guy where I can send out that amp gauge and he converts it to a volt gauge so that the dash now is 100% functional. I mounted the Super Duty four-wheel drive selector right here. This would, if your car has AC, this would be an AC vent. This cluster or dash bezel was made for a truck without AC, even though this one did at one time have it. But it made for a perfect mounting location, so I have my four-wheel drive mount there. Down below here, this is where I mounted the fuse box. So I have my OBD2 port here, my fuse box, which is, you know, nicely tucked out of the way. You can access the fuses from underneath just fine. If you need to get, you know, to the back wiring, this little tab here, and the fuse box will hinge down. The only thing I haven't put up yet is this is the overdrive switch, which is normally found on the gear selector shifter. You know, since we tried to maintain this thing with all originality, I don't have that stock on there, so you know, I just need to find a place to locate this. It is helpful because if there is a fault in the transmission, the light on here will flash to indicate some kind of error code in the transmission, so I do want to retain that. But that's basically it for underneath here. Alright guys, so I know this looks like a lot of goulash, but you know, there's two separate truck harnesses here that I integrated into one. The 2002 model truck had a lot of wiring that needs to go to and from things, and you know, like I said, I condensed a lot of it, but I didn't shorten it. You know, I just left all the lengths. I didn't want to have to cut each wire and solder everything back together so I had good connections. I felt like that was just going to lead to problems down the road. So, you know, it does look a little crazy in here, but at least, you know, everything is tied in there as best I can. I did also keep this here is what's left of the 2002 cluster wiring, and the reason why I kept that is because I could still plug that into the factory cluster, and I can see things like the speed, the tach, some of the warning lights, stuff like that. So you know, if I need to see any of that information, I can. I can tell you it did come in handy when I was programming the signal interference module from Dakota Digital for the speedo, because I was using the speedometer from the 2002 Super Duty cluster, and I was able to calibrate it with the GPS and set the signal properly so that the ECU sees the right mile per hour. But what I'm working on buttoning now, I wanted to show you guys, there's my updated volt gauge. So as you know, the original one was an amp meter. Since this truck makes way more amperage than it once did, you know, hundreds of amp, that voltmeter, or the amp meter rather, wouldn't have worked. So I found a guy online, Rocket Man. I'll put a link in the description below. He does mostly, I think, probably got started on Cougars because his website has a lot of Cougar information, so a lot of Fords and stuff. You can look it up. He does tachometers, he does volt gauges, he'll rebuild all the gauges if you want. So I'll put a link in the description so you can check him out if you're doing something similar to this. But right now, since I did all my wiring modifications that I needed to do to get the volt gauge to work, basically all I did was I took the two wires that used to go to the amp gauge, and I wired them up to the positive and the negative of the cluster power, because that is ignition power. That way that volt gauge will work from key on, and now I didn't have to make any modifications on the printed circuit board back there. So I just wanted to show you guys basically, you know, the mess of wiring I have underneath here. What else? Oh, the only other thing I can point out to you is this. This is the electronic speedo drive now. Takes the speed signal from this guy and puts it into the box that I mounted here. There's a little motor in there, drives this cable, and then I have a functional speedometer. So that's pretty cool. This guy as well can be calibrated depending on if you change your tires or your rear axle and something like that. So that was a pretty trick little device there. Okay, so looking under the hood, as you can see, I now have an air filter on this thing. I relocated the little breather section here that went from the snorkel to the factory air box, and that way I have a small piece of tube underneath, so it goes to the engine crankcase breather, takes care of all that. Got my air filter rigidly mounted to my little rubber mount here that I made for the radiator, or the intercooler I should say. And then all my computer and electronics mounted very nicely, all the connectors mounted to the inner fender well so they're easily accessible. Made for a really clean installation here. So, as you can see, everything packaged in here pretty nicely. Don't mind this. This is stuff for the truck, vacuum for the heat control, and one of them is actually for the washer nozzles, but right now we don't have that. So basically everything under the hood right now is done. As you can see, I have a lot of the front end together. I do need to replace the straight water I have in here with coolant. I put straight water in just to make sure everything was working in case I had to drain it out. I didn't want to have to waste antifreeze. This thing sounds incredible now. It should have plenty of torque now to move these giant tires. Pretty excited about that. And everything's sort of been a big milestone with this thing, not knowing how things were going to fit, if the electronics were going to work once I removed all that other stuff that we don't need. And just being able to get everything to function has been a pretty big undertaking. All right, guys, final steps on this thing. I'm really excited so we can actually drive this thing, make sure everything's working, give a full shakedown. The last thing I want to do is I quickly checked the alignment the other day. This thing's towed out almost 3/4 of an inch. What that's doing is making it so it'll wander all over the road. Lifted trucks, usually I want to set this thing about a 1/16 of an inch toe in. I don't have an alignment machine, so I'm going to use a tape measure and some straight edges off the tires and just try to get this thing close enough for now. That way I could drive it. It shouldn't wander all over the road. Well, I mean, giant tires on here, it's going to wander anyway, but we can get this alignment set up and then we can drive it. All right, guys, so I have my helper here.
Hi.
She's not touching it because it's full of spiders.
Lots of spider webs.
But what we're going to do here is I'm going to send the tape measure from the other side of the truck. Just going to hook it on both ends. We're going to take a measurement from that side to this side. And basically what I want to do is, looking at the front of the truck, I want to get these front tires to point in a 1/16 of an inch. So measuring from the back and from the front, I want the front measurement to be a 1/16 inch smaller. So, like I said, we're just using a tape measure, some straight edges, got a level on the other side. I'll try my best to try to film this one-handed here. Okay, so my measurement on the back here looks like I'm about 88.5. So now we'll take the measurement from the front. Okay, guys, so my link bar here that I made up has left and right hand threads. So basically what I want to do, since I want to bring the front of the tires in, is I'm going to shorten the distance between these two tie rod ends. And like I said, because it has left and right hand threads, all I have to do is turn this thing one direction. I don't have to take anything off, just have to loosen the jam nuts. And that should shorten the distance between the front. So it should bring the front of the tires in. We'll take another measurement and we'll make sure I get that 1/16 of an inch that I'm looking for towed in. So let's take a measurement. Okay, so my rear measurement now is about 89.1/8. Okay, and my new front measurement here looks like it's 88 and call it 9/16. So I've gone a little bit too far. I'm going to make it a little bit longer and we'll check it again. Okay, I adjusted it again. My new measurement here looks like we're about 88 and I don't know, what are we there? Looks like we're about 88 7/8 on the rear. So let's measure the front. Okay, and my front measurement here is 88 13/16. So that's just what I wanted to get. I wanted the 1/16 of an inch toe in on the front, and that's pretty close. Okay, now that my measurement is where I need it, I'm going to tighten my jam nuts back up. I'm going to reposition my steering shock absorber here, tighten it down, and then I'm going to go through and I'm going to give this thing a full bolt check, make sure everything here is tightened. I believe I've already gone through and greased all my ball joints that I had here. So those are good, but this is exciting. I'm going to tighten all this stuff up and we could take it for its first drive. Alright guys, as you can see, I've got the dash all back together, all the hardware in, got my new volt gauge in there, all my gauges that are now functional. There's my four-wheel drive selector, so it's almost like factory. And yeah, let's take this thing for a drive. Let's get this thing fired up. So first things first, I wired up the brake light bulb as my alternator dummy light. It sends power to the alternator to energize the field. This light will go off once it starts. I don't have a glow plug light in here, but the owner of the truck does drive a lot of diesels, so he knows to wait before you start. So it's basically that simple. Let's crank this baby up. See my brake light switch alternator light has gone out. There's my oil pressure's coming up. Even my fuel gauge works. And yeah, what else do we got here? So I was able to utilize the original column shifter. I basically adapted the cable to the column shifter here so we can put this thing right into reverse, neutral, drive, second, first, all the way through the gears, so that there's no funky floor shifter or anything there. I do still, however, have to put a plate here for the old four-wheel drive shifter, since we no longer need it with this one. But yeah, my alignment's done. Let's take this thing for a drive, and then I could center my steering wheel to, you know, whichever way the wheels are tracking straight. Alright guys, I know I look really low in here with the camera angle set up, but let's take this thing for its drive. So right now I basically have it on the stock tune. I don't need it to do anything kind of crazy. Just want to make sure it's shifting through the gears right. Everything feels good. No crazy vibrations, anything like that. And then after that we can start playing around more with how its performance is. Brakes feel really good. You know, we were a little worried about the brakes. You know, this thing had the big block in it, had vacuum brakes. The brakes weren't the greatest, but now with the Hydro Boost, this thing stops no problem at all. I don't know if you can tell on video, but this thing is really bouncy. I mean, the suspension in this thing is really stiff. I guess it's expected, you know, you have compromises when you want tires this big. But so far so good. It's going through all the gears right. Plenty of power. The second gear. Our third gear. fourth, or maybe it's overdrive, I'm not even sure. You know, these will shift really soon, really subtle like. I got a functional speedometer, which is great too, and it's calibrated to the size of the tires. Is my functional speedometer. As you know, guys, I got the Ford R100 transmission, so that does not have a cable drive output. So I have a cable drive speedometer that's driven by a motor, and you can see I've got my functional speedometer. All my gauges are looking good, coolant temperature's good still. I am in a little bit of traffic here, I can't really go terribly quick, but you know, so far this thing is running great. As you can see, my steering wheel's a little off, so I'm going to center that thing up, tighten that bolt. But that's it. Alright guys, I'm going to go drive this thing around a little bit, center my wheel, make sure everything's good.